Okay, so here is the last set of notes for Unit 1. Yay for you. Okay, suppose I took a random sample of 9 students and recorded their score on a recent quiz. Their scores are listed below. Okay. Hopefully this quiz was out of 50 and not 100. Sketch a dot plot for this distribution, and then we're going to find the summary statistics. So we have 1 at 30, 1 at 35, 1 at 36. So that's my distribution. Then I could find the summary statistics by hand, but I'm entirely too lazy for that, so let me get to my calculator. Okay, so I'll just go to Stat, Edit, and in there, in List 1, I've put all my data. Then I can go to Stat, Calculate, one variable stats for List 1, and I've calculated those. Okay, so we have an average of 40.4. Approximately a standard deviation, we're going to use a sample because this is not my whole class, of 6.1. There are 9 students. And then if you push down, you can see the min, Q1, median, Q3, and the max. Write that down on your paper. You may need to pause it, and I will flip over to the other page. Okay, so you should have written that down, but here they are. We have a min of 30, a Q1 of 35, a median of 40, a Q2 of 45, and a max of 50. Okay, our range is just, again, 50 minus 30, or in other words, 20. Okay, and our RQR comes from 45 minus 35.5, which will give you 9.5. Okay, so there's our statistics. Now suppose I was feeling especially generous and added 5 points to each score. Okay, sketch the new distribution with the same scale, that's a key so you can see what's going on, and recalculate the summary statistics. Okay, so I'm going to do it again. I could just do that in my head. So we were at 30, so now we're at 35, 40, 41, 45, 45, 48, 50, 50, 55. So again, I'm just adding 30 plus 5 is 35. And now I'm going to go ahead and plot that. Hopefully what you notice is that it's the exact same distribution, just shifted over 5. Okay? If you didn't want to do that by hand, you could again go to your calculator. Okay? So go back into Stat, Edit. You could just type in 3540 into here, or if you had lots of data, go up to List 2. So it's highlighted and this is blank. And then you hit blue to get List 1. And we want it to add 5. Hit Enter, and now it's added them all. Then you can go into Stat, Calculate, one variable stats. This time change this to List 2. And there are your new statistics. Please write that down again, and I will flip over to the notes. Okay, so if you've written it down, you should have gotten, oop, I should have done my picture green, oh well, a minimum of 5, a Q1 of 45.5, a median of 45, Q3 is 50, max is 50, an approximate average is 45.4. Okay, I could have written it like this instead. X bar is approximately 45.4 and left off that it's repeating my standard deviation, range, and my IQR. Notice what changed and what didn't. Okay. Did my range change? No, it's because it just shifted. Did my IQR change? And the answer to that should be no. If I had written down correctly, this should be 9.5, not 8.5. Okay, so that did not change either. What did change? Well, all of these changed because they were shifted, as well as the average. Notice that the standard deviation did not change because the numbers still have the same spread. Alright, so now let's go back to the original data and assume that the quiz was out of 50 points. Oh good. To convert these scores to percents, we could multiply each of them by 2, since 2 times 50 equals 100. Sketch the new distribution, which was this, we want the same scale, and recalculate the summary statistics. Which one changed? So again, you could do the same thing, go back to your calculator, go into List 3, multiply everything, and you would get, or you could do it by in your head, 60, 70, 72, 80, 80, 86, 90, 90, and 100. I'm going to go ahead and plot those. Look very carefully at that. It's the same shape, but this time it is more spread out. Okay? It's about twice as spread out, and you should see that in your summary. Okay? Instead of having a range of 20, our new range is from 100 minus 60, or 40. It's twice as big. Similarly, our IQR, it's twice as big. The average is also twice as big, okay, as well as the standard deviation. So the bottom line there is when you add and subtract, everything changes except for the measures of spread, standard deviation, range, and IQR. But if you multiply or divide every data point, everything changes. Okay, welcome to part 2. We have one last example. All right. A Manhattan taxi cab company studied the lengths of taxi rides and computed the following statistics in miles. Okay, so on average they had rides of 4.8 miles with a standard deviation of 4.2 miles, a median of 3.6, Q1 of 1.8, Q3 of 5.9, and an IQR of 4. If they converted the mileage measurements to kilometers, what will the summary statistics be in kilometers? This is a reason when you would actually scale data in the real world. And in order to do it, you would take every value and multiply it by 1.62. So to begin with, the mean of 4.8 times 1.62. Because remember, when we were up here, when we multiplied, everything changed. All of the median, standard deviation, range, and everything. So we're going to multiply all of it by 4.62. Or sorry, 1.62, and here we get 7.78K. If we did the standard deviation times 1.62, we'd get 6.8 kilometers. If we did the median and the quartiles, okay, we would get this. And all I'm doing is multiplying by 1.62. You may need to pause to write that down. All right, so that's just a standard scale. Notice that everything shifted. Here's something more real world. If the cost of a taxi ride is $2.50 plus $3.20 per mile, what are the summary statistics for the distribution? Okay, well, we can write a function, a cost function, so C for cost, where we plug in the miles that you go in the taxi cab, and it'll tell us how much you have to pay. Well, $2.50 just to get in the taxi. That's called the flag drop fee. Notice I left off the 0 because I don't really need it for math. Plus $3.20 per mile. Now we're going back to miles, so we're going to go back up to this original data right here. It says, what are the summary statistics for the distribution of the costs? Well, we have to think about it. What we need to do is think about what happens when we add or subtract to data. Okay, up here when we added a 5, a lot of stuff changed, but the measures of spread, the standard deviation, range, and IQR, did not. And so we are taking our value, we're going to multiply, and we're going to also add to it. We are going to ignore the adding for standard deviation and IQR because it doesn't do anything. The multiply and divide, though, does. So let's do everything but standard deviation first. We have this function. So if they went 4.8 miles, we plug the 4.8 miles into the function. Cost 4.8 miles, that's 2.5 plus 3.2 times 4.8. And if we do that really quick, we get 17.86. So it's going to cost you $17.86 on average. For the median, if we were to do that, okay, we plug in now 3.6 because the median miles is 3.6. We get 2.5 plus 3.2 times 3.6. And we should end up with 1402. And you could do that the same for the quartiles. So you plug in 1.8 into the full equation, and you would get 8.26. I really should label that dollars. For Q3, plug in 5.9, and I should get 21.88, it looks like. Again, you may want to check me on that. But for the standard deviation, we don't want to include the addition of 2.5. So all we're going to do is multiply. So we're not actually sticking it in the cost equation. We're just scaling it. 3.2 times 4.2 with a standard deviation of about $13.44. You very well may have questions on this. Come to class prepared to ask them. Again, with the IQR is 4.1, and we're going to times that 3.2 times 4.1, and the interquartile range is about $13.12. Okay? So when you have to do any adding or subtracting, you can just use the full function. Everything that happened to it you can do to any data point. But if it's an actual measure of spread, you only want to do multiplication or divide. That ends our notes.